It's March 18th, Wednesday, School from Home Day, assignment number 2 for us. So if you will notice, today you are going to be watching this awesome YouTube video on how to graph rational functions. You need to be writing notes while you view this YouTube video. You will be submitting your notes on the Canvas page instead of sending me a picture through Remind. So this is different from day 1. On day 1, you submitted a picture through the Remind app of your Delta math problems. Today, you're going to be submitting those through Canvas, and it should be very easy to find. You actually should find it right below the link from this YouTube video. Please make sure to look for this assignment on the Canvas page. Okay, guys, we have been talking about solving rational functions, which is what you did your Delta math assignment on. Now we're going to start graphing these wild things. Now, if you'll notice, these graphs look a little bit crazy, different from any graph we've ever graphed before. If you'll notice the graph, the curve, this one has 2 curves here. We also have the thing that we like to talk about. We call them vertical and horizontal asymptotes. So these are definitely 2 crazy, different looking types of graphs. There are 8 whole steps to graphing this. It might be good to jot down these. What I'm trying to do for you to make this a little bit easier is we're just doing steps 1, 2, and 3 today. We are not going to venture into steps 4 through 8 until Friday. So 1, 2, and 3, I thought we'd take it as a small little area. We're going to talk about finding y-intercepts, finding the x-intercepts, and finding the vertical asymptotes. So those are the 3 things that we're going to focus on today. So let's get started. Now, if you'll notice, finding the y-intercepts is kind of our first step. It doesn't really matter if you find the y-intercept or the x-intercept first, but those are just common coordinates that we want to find. This is a reminder of what y-intercepts are. They're the place where the graph crosses the y-axis. Another characteristic of a y-intercept is that x is always 0. Another thing is that the value is a coordinate, and it will always be 0, something, and that something is going to be a value that we find on the y-axis. Now, if you will notice, it tells me even how to find the y-intercept on our new rational functions, and we'll get started with this in just a minute when we do some examples. But this tells you the steps on how to find it. You might want to write this down on your notes. To find the y-intercept, you plug in 0 for x, and the answer is the other part of the coordinate that we find here. In general, x-intercepts, you've come to know, is the place where the graph crosses the x-axis. Y is always 0, and the value is still, again, a coordinate. Now, here's some basic examples of when you've had x-intercepts before. You've had x-intercepts here, here, and here. Remember, we used to call x-intercepts, it had 4 names. It was solutions, roots, x-intercepts, and then zeros. So those are all common terms that you've used when you found x-intercepts. But now it's going to be kind of a different process for the rational functions. Now, you may be wondering why I'm mentioning vertical lines on this next part. If you'll remember or recall, step 3 is to find the vertical asymptotes. Well, vertical asymptotes are essentially vertical lines, but so I wanted to remind you of a couple of concepts with vertical lines. The slope is always undefined here on a vertical line, and the equation is always x equals a number. So when we're talking about equations of vertical asymptotes, it will be x equals a number. If you'll notice here in this example, x equals 3 would be our equation of that vertical line. So that is coming soon with your vertical asymptotes. Okay, if you will notice at the top of this, we have a goal for today. Our goal for day 1 of learning about graphing for rational functions is to find the y-intercepts, to find the x-intercepts, and to find the vertical asymptotes. If I were doing this, I would make a note card, and I would have these 3 reminders on my note card. You don't have to make a note card. It would be a great idea. But these are definitely 3 things that you need to write down. This is the whole point of today's lesson. To find the y-intercepts, you're going to make x equals 0 and simplify. To find the x-intercepts, you're going to set the numerator equal to 0 and solve. To find the vertical asymptotes, you're going to find it by setting the denominator equal to 0 and solve. Now, obviously, I'm going to show you 3 examples where we do all 3 of these steps so that you will be successful on today's problems. Okay, here's our first problem. It is f of x is equal to 3x over x minus 2. Please make sure you write that down. 3x over x minus 2. Our step 1 is to find the y-intercept. So to find the y-intercept, you'll recall on our notes, we're going to make x equals 0 and simplify. So everywhere I see an x, I'm going to put a 0. So it turns out to be 3 times 0 over 0 minus 2. Everyone knows that anything times 0 is 0. So I get 0 over negative 2. What that means is my y-intercept, so my value is 0. So my y-intercept, we'll recall we always said x is equal to 0. So our coordinate for our y-intercept is 0, 0. Next, we have to find the x-intercept. So on our steps that we just wrote down, we had to find it by setting the numerator equal to 0 and solve. Well, in the numerator is a 3x. So I'm going to say 3x is equal to 0. I solve by dividing by 3. X is equal to 0. So you have an x-intercept at 0. So it looks like on this problem, the x and y-intercepts are going to be at the same location, which is perfectly fine. Next, we have to find the vertical asymptotes. Here, if you'll recall, asymptotes are what we call undefined places. So if you'll recall on the last test that we had, I made a big deal about these things called excluded values. It's the same thing as vertical asymptotes. So if you'll recall, when we did excluded values, we took the denominator and set them equal to 0. So that's exactly what you do for vertical asymptotes. I'm going to take the denominator and set it equal to 0 and solve. So I'm going to add 2. So x equals 2 would be our vertical asymptote. You can abbreviate it with a V and an A. Okay, for example number 2. You'll notice it's f of x is equal to 3 over x. This is a rational function because it's a fraction that has a variable in the denominator. So with that in mind, we start the same process that you just did. We're going to find the y-intercept. To do that, we're going to make 0, plug in 0 in for x. So everywhere I see an x, I'm going to put a 0. This one is going to be 3 over 0. Uh-oh, what happens when we have a 0 in the denominator? Undefined. So what that means is this does not have a y-intercept. Okay, so you would write no y-intercept. You'll understand this in just one moment. Next, x-intercept. In this case, we're supposed to take the numerator of the fraction, which is a 3, and set it equal to 0 and solve. So does 3 equal 0? I'm pretty sure that's not true. So weird things are happening with our x and y-intercept. So there's no x-intercept. Weird. Okay, let's check out the vertical asymptote. To find our vertical asymptote, we set the denominator equal to 0. When the denominator is just an x. So x equals 0. Ding, ding, ding. That is why we do not have a y-intercept or an x-intercept. It's because eventually, when we graph this bad boy, you're going to have an undefined place going through the middle, like so. So that's why there was not an x-intercept or a y-intercept for this. For our third and final example, we have f of x is equal to a negative x plus 4 over an x plus 1. To find our y-intercept, we're going to find every x and plug in a 0. So I'm going to have negative 0 plus 4 over 0 plus 1. This ends up giving us a simplified version of 4 over 1. Remember, the x-intercept is a coordinate. So you would say 0, 4 is your y-intercept. Next, for your x-intercept, you're going to take the numerator, in this case it's negative x plus 4, and set it equal to 0. I would subtract 4, and then I would divide by negative 1. X is equal to a positive 4. So the x-intercept here would be 4, 0 as a coordinate. Your last step would be to find the vertical asymptote. Take the denominator, x plus 1, and set it equal to 0 to find that excluded value or undefined space. X cannot be equal to negative 1 is what we used to say it. Well, now we know it's the equation of a vertical asymptote. So this is what you'll need. Now, for today's class, you will be finding 12 problems on the Canvas page. For those 12 problems, you will be completing steps 1, 2, and 3 of the graphing process, which is the x-intercept, the y-intercepts, and the vertical asymptotes. Now, don't lose that work from today because we'll continue to work with those same 12 problems on Friday's assignments. And as always, if you have any questions, please don't hesitate to reach out to me through the Remind app or through my email. You guys have a great day. See you later.